Now, we want to quickly look at these two problems that back up the one way explanation of Coulomb's law that we did in our last class. Now, if you have not watched that video, please go and watch so that you can correlate with the question we want to solve now. Now, the question says, what, number one, we have two questions here. Number one says, what is the magnitude of the Coulombic force between 2-point charges Q1 equal to 3.0 microcoulomb and Q2 minus 4 microcoulombs. Now, it says separated from each other by a distance of 15 centimeter in air. So distance is what? 15 centimeter. 15 centimeter, as you can see it, is there. So now the 15 centimeter you convert to what do you call it, to meter. By dividing by 100, you have 0.5 meter. Now in air, what is the nature of the force? First of all, we are going to find the magnitude. To find the magnitude of the force is what K in the air, it occurs in air, so K naught Q1 Q2 divided by what? R squared. Now, when we do that now, what I want to do is that your K is having a value of 9 times 10 power 9 Newton meter square per coulomb square. Then our R is what? It's already given. So what is winning? So the magnitude of the force we just what? 9 times 10 power what? 9, which is K naught. Then absolute of what? 3 times micro is what? Minus 6. Minus 6. Absolute of what? Minus 4 times 10 power what? Minus 6 also. Then divide by what? Don't forget, this is negative charge, this is positive charge. Now, what we are doing now is that the distance of separation is what? 0.15 all square. Look at a rough sketch of what had just happened. This is what? Negative 4 microcoulomb minus. This is what? Positive minus a plus 4 plus 3 microcoulombs. Automatically means that if these two interact, they will attract each other. Don't forget the separation is what? 0.15 in meters. So in this case now, they will do what they call, they will exist. What will exist here is force of what? Attraction of the two of them. So what is the magnitude of this force? That's what we are looking for. That is the force we have. So our magnitude of the force will now be equal to what? The absolute, we cancel out this minus. So I would have what? I would have what? Divide by what? 0.15 what? Square. Okay. What I did was 9 times what? 3 times 4. Then divide by what? This will give us what? 4,800 times. Then you now applying this one now will give us what? Minus 12. Minus 12 times what? 10 to the power minus 9. 10 to the power minus 12 times 10 to the power minus 9 will give us 10 to the power minus 3. So 1, 2, 3. So that will now give us 4.8 Newton. And what will be the force? Attraction. So attraction will be the force of attraction. So that will be your answer, and the nature is what? Attractive force. Don't forget. So in this case now, why is it attractive? Because unlike charge will be attract, while like charges will what? Will repel. So that is the final answer for what? For this one. You just see 1, 2, and you see the decimal point, you get 4.8. So our force is what? 4.8 Newton. This is F. Then the nature of the what is what? Attraction. The nature of what is attraction. So you find attraction force as the nature. Then you find what? The nature of this attraction, the what? and it will occur in air with a force of what? 4.8. Now, the next one is the second question we want to look at, which is the last question. So, let me just clean the one we have solved, and let's look at the next one. Now, the next one says what? Okay, number 2. Say two identical coins separated by a distance of 2.0 meter in a large vase of liquid carrying what? Identical coin. Underline two identical coin separated by a distance of what? R is equal to what? 2.0 meter in a large vase of liquid carrying identical charges. So that means Q1 is equal to Q2 or equal to Q. That's what it means. Now, if the dielectric constant of the liquid, that means epsilon R is what? 50. Calculate the magnitude of each charge if the repulsive electrostatic force is 20. So that means F magnitude is what? 20 Newton. Don't forget, this is what we also call relative what? Permittivity, and it has no unit. It has no unit. If you check, there's no unit given to you now. So it's because why? It's divided by, don't forget that epsilon naught over epsilon R. Epsilon naught, epsilon R divided by epsilon naught to give us what? Epsilon R from the previous, with what the last chapter we did for back of this solution. That's what I give. And this one is measured in what? Is measured in Coulomb's square per meter square per Newton. So the two of them have the same unit. So if you now divide what we have, you do not have any unit now. So take note of that. Now, I gave you a formula in that class that what? That says what? If the charges are identical, what happens is that what? K naught, epsilon 1, epsilon 2, all over what? Epsilon R times R squared. F equal to K naught, Q1 rather, not epsilon please. Q2 divided by what? Epsilon R squared. This is what? In a medium. I said it. I think the first question was talking about in air. Not I think, it's talking about in air. Why number 2 is talking about in medium, in a medium. Now, if you make Q the subject of formula here, like what we did, because Q1 is now equal to Q2, what you are going to have done is that F will now be equal to K naught Q squared over epsilon R squared cross multiply by what I have what? F naught times epsilon R times R squared equal to what? K naught Q squared. Divide both sides by K naught. So Q will now be equal to, take square root of both sides to what? To remove this square, you are going to have what? Square root of what? F absolute times what? Epsilon R times R divided by K naught. So let's put our value there. Now what is our F absolute? 20 Newton times what's our R? Our R, okay, R is what? 2.0. Then epsilon R is what? 50 times what? 2.0 meter all square. Divide by what? What is this? 9 times 10 raised to the power 9 Newton meter square per column. Now, having done that, if you do your analysis, one times this is 1,000, this is 4, this is 4,000 divided by this is, so 4,000 times divided by this, we are going to have what? 4,000 divided by 9 times 10 raised to the power what? 9. That will give us square root of what? This one will cancel one of this one, remaining 10 raised to the power 8. So I want to have square root of 400 is 20. Square root of what? 9 is 3. Times square root of what? 10 raised to the power 8 is what? 10 raised to the power 4. So if you do your calculation very well, or you use your calculator, just finish everything so that you don't waste your time. Just do it directly. 4,000 divided by 9 times 10 raised by what? 9. So that the answer will be what? 6.67 times 10 raised by minus 4. 6.67, which is 20 divided by 3, 6.67 times 10 raised by what? If you go up, you have 10 raised by minus 4. So this is our answer, Coulomb's. So charge is equal to, the charge is equal to what? 6.67 times 10 raised by minus 4 Coulomb. Having gotten that, now we have solved the first question. The first question says calculate the magnitude of the heat of the charge. So the heat of the charge is what? 6.67 times 10 raised by minus 4 Coulomb. Now another thing again you have to now solve is what? They say we should find the number of electrons on each coin. So let me wipe up this part. I don't need any of this one again. So to find what number of what? Of electron on each coin. What you are going to do is that Q absolute is equal to NE according to principle of quantization. So N is equal to what? Absolute of Q divided by E. Don't forget E is what? 1.6 times 10 raised by what? Minus 19 Coulomb. Don't forget that. Very important. Then substitute it into the equation. We have already gotten our charge. So what you are going to have now is what? What we are going to have now will now be equal to what? N will now be 6.67 times 10 raised by minus 4 divided by what? 1.6 times 10 raised by minus 19. If you are applying indices for these two, you are going to have 10 raised by 15 first. Then 6.67 divided by 1.6. 6.67 divided by 1.6. So I would have 4.168. 4.168 times what? Times by what? 16875. But approximately to the nearest whole number, you are going to have what? 4 times what? Times by what? 15 what? Electrons. So this is the number of electrons that you are going to have in what? In each of the coin. This is number of electrons. No, there exists as a whole number. So I just try to what? Take it to what? To the nearest whole number. That means to the nearest what? What do you call it? The first what? Significant figure. So that is what I'm going to have. But this one is not up to 5. It's 1. So you cannot add it to this. Assuming it's 4.568. I want to make this one 5. So that will be your answer to the question. So I believe you have been able to enjoy yourself. In case you have any one or two things that is not too clear, you can still type us and message us on the comment section. If you enjoy the class, send us message to encourage us in the comment section. All this will go a long way to encourage us to do more. Thank you for watching. Have a wonderful day.